Hi everybody, my name is Danica Fine. I realize now I did not put my name on there, so that's great. It's at the bottom. There's my Twitter handle. You can find me, I promise. But yeah, my name is Danica Fine. I am a developer advocate with Confluent, and I'm so excited to be here. Like, I hope you're as excited as I am to be in person at an event, getting back into the swing of things, being at conferences, seeing people in real life. Okay, you're clearly not that excited about it. Okay, I'm sorry. I am very enthusiastic about being here in person. Like I said, it's weird getting back into things and like leaving your house. I was afraid that I wouldn't be able to do it. But anyway, on that note, actually, last 2 years, been kind of weird. How many of you picked up some hobbies over the last couple years? Or maybe like threw yourself at hobbies? Okay, all right, cool. Some of you. I feel like some of you are lying, but that's okay. So for those of you who are honest, how did that go for you? Yeah, okay, I see mixed reviews. And I feel like hobbies over the last couple of years, they went one of two ways, right? You either threw yourself into it 2 days in, you gave up, or you dove in, and now that's your life, right? I have a hobby, and I'll let you decide which one of those things it was. It kind of got out of hand. I've had houseplants for a number of years, really got crazy the last couple of years. You know, you're at home, you want it to look nice. It's nice having a living thing there that's not a pet. Yeah, I have like 4 dozen plants. It's insane. Kind of a problem. And it became more of a problem the last couple months when I want to leave my house and go do other things. But I like them. I want to keep them alive. So I was spending an hour or so a day checking on my plants. Yeah, to make sure they're alive. They're kind of needy. You need to water them. You got to check to see if they need to be rotated. It's kind of a mess. And I wanted to leave my house. I wanted to go back and do things, all right? So, and then beyond that, it's just like, I was just being a bad plant mom, okay? Like, this is embarrassing. This is a very dramatic plant. He's okay. But things like this would happen. And it's because I forgot to go check on my plants that day. So I figure I'm an engineer. Okay, I know how to build things. I've got a lot of tools in my tool belt. Is there a better way for me to be doing this? Can I monitor my plants? And I know what you're thinking. There are definitely better ways. There are products out there. I can go buy a plant monitoring system. So that's the wrong question to be asking. Okay, that's better, all right? That's what we want to do as engineers, right? Build something interesting, all right? So I figured, again, I have the technology in my pocket. Is there some tech that I can use and maybe like mix it with some willpower and I can spit out this really cool monitoring solution so that I don't forget to water my plants? And beyond this, I've always wanted an excuse to build out a project with Raspberry Pi and any sort of hardware thing, so this was my chance, okay? I had a ton of time at home and I was gonna do it. So let's talk design. This is like back of the napkin sort of design, right? Very, very high level. I needed something to monitor my plants, all right? And let me know when I needed to start paying attention to them and acting on it. So the system I envisioned was pretty simple. I'd place some soil moisture sensors in some of my plants and take these readings, and I'd put that somewhere. I don't really know where I was going to put it at that moment. But then I also needed some metadata maybe, and I love saying metadata. When you're first starting to plan out a project, it's like that's that weird word that you use to catch everything. Like, I need some more information here, but I'm not really sure exactly what information I need yet. But I knew then that I needed some additional stuff to actually decide on if I needed to water my plants and do something with them. So I'd take those readings, enrich it with that very, sort of hand-wavy metadata in there, and throw it into a black box that was maybe Kafka, because I like Kafka, and spit out an alert, hopefully. And hopefully I'd get it on my phone too. That would be really nice. So this is a very, very, very high level view of what I wanted to achieve, right? And the only things that I knew for certain at this point was that I was using a Raspberry Pi, because it's a bucket list item for me, and that I wanted to use Kafka, because I figured I'd be taking these readings in real time, and I should probably use some sort of real-time system to make use of them. So for those of you who aren't familiar with Kafka and who didn't attend the other Kafka talk this morning to get a primer, I just want to make sure that everyone is on the same page here. So Kafka is a distributed event streaming platform. And that's 5 words, 5 little words, but they're jam-packed, okay? There's a lot to unpack there. So let's break this down. It's a distributed event streaming platform. So you may have noticed over the last couple of years especially that we're undergoing this sort of paradigm shift, right? We're moving from Processing data in batches, so this sort of slower moving process of collecting information over a couple minutes, hours, days even, and then spitting out some result at the end of that. And we're moving from that to real-time processing, where instead we consume information as it's processed, or as it's created, and then producing some sort of incremental result as we process that piece of information. So this happens more quickly in real time. So this move to stream processing or streaming can help to, there's a lot of benefits of it, and there's a ton of other talks out there to convince you that you need to move to stream processing, but to sort of give you the spark notes on it, it increases the accuracy of your data and your results. Your stakeholders are going to be happy because they're going to be receiving data in real time more quickly. You're going to be more reactive, and you can also use it to increase the resiliency of your overall system. And Kafka is a pretty convenient platform that does that for you. It serves as that messaging layer so that you can communicate between different areas of your system. You can use it as a persistent storage layer, and then also the most important part, I think, is that processing layer. You can use it to process information in real time. But to really use Kafka to its fullest and get the most out of it, you need to start thinking in events, because it is a distributed event streaming platform, okay? That's crucial. So what do I mean by thinking in events? So I'm going to preface this by saying that you already do this, okay? As humans, as programmers, as users, you already think in and process in events. It's a very natural way to reason about your life, okay? I promise you already do this. You submit web forms every day. You're interacting with these things online. You look at application logs. If you're debugging something, you are reacting to notifications on your phone. You're already messing around with events. Events are everywhere. So I'm just asking you to be a little more cognizant of the fact, because that's going to help you embrace Kafka just a little bit better. So those are examples of events, right? But what is an event really? An event is a piece of information, ideally the smallest amount of information without too much excess, that fully describes something that has happened. Okay, hopefully that seems intuitive as a definition of an event. So in order to describe an event, describe something that has happened, what do we need? We need a timestamp. We need to know when that actually happened. We need to know the subject of that event, who or what was involved, and we need to know any supporting details, like what actually happened. So, for example, going back to my plant thing, so this is my umbrella plant. So yesterday at 2:30 p.m., suppose that my umbrella plant had a moisture level reading of 19%. Okay, so we have that that timestamp yesterday at 2:30 p.m. We have the subject of this, the plant in question, and the supporting detail. It had a moisture reading of 19%. So that is an event. See, they're everywhere, okay? You already think about it like that. But another key component of an event is that they're immutable. And this is just due to the fact that they describe things that have already happened, okay? And it's an unfortunate fact of life, because some other ways, you reason about things in programming languages, immutability isn't that important. But in events, it's a crucial thing about it. And it's an unfortunate fact of life, okay? You kind of have to just accept that, right? I don't have a time machine. I can't go back in time. I can't go change anything that has already happened. So going back to the plant, if I go ahead and water that plant and raise its moisture level to 70%, say, that doesn't change the fact that it still had a moisture level reading of 19% yesterday, right? So we've simply added, by watering the plant, we've simply added another event to that stream of immutable events, right? It's a timeline of events. So based on what you just heard about events and how Kafka can facilitate the movement of smaller pieces of data around your system, it's pretty cool. You kind of see how it can help you with real-time processing, right? Kafka allows you to communicate that immutable events are occurring throughout your system, and then gives you the power to process those pieces of information and react to those events in real time, which I think is pretty cool. If you're not already using Kafka, it's a wild way to re-architect your systems. I definitely suggest it. But how does it do that? So let's look a little deeper into the Kafka architecture, okay? Because it's a distributed event streaming platform. All right, so this is going to be a pretty wild and quick primer. All right, I recommend there are some other talks that spend the whole time talking about Kafka, so you might want to check into a couple of those. But primary unit of storage in Kafka is a Kafka topic. And topics typically represent an individual data set consisting of events, all right? And we produce these events into Kafka as key value pairs. We use separate clients called Kafka producers to write that information into Kafka, and we can have as many producers as we want, producing to as many topics as we want. From there, once the data is in Kafka, we use a separate client called a Kafka consumer. And again, we can have as many consumers as we want, consuming from as many Kafka topics as we want. And we can even have the consumer share the work of reading information from a single topic, right? But they're also free to consume that information from the beginning on their own, independent of other consumers, all right? And that's a really important thing in Kafka. A Kafka topic is not a messaging queue. I know if you're trying to, if you're looking for another technology that might be kind of similar, messaging queue usually comes up. And that's not what Kafka is. When data is consumed from a Kafka topic, it doesn't disappear, all right? And the topic is a log, and similar to application logs. Think about the last time you had to debug an application. You're going through the log file, line by line, trying to figure out what happens. As you read that log line, what happens? Nothing. It's still there, right? So if you need help debugging and you ask your colleague to come in and reread the log file from the beginning, they are still free to read that. That information is still there for them to consume until the log file rolls. It's the same thing in Kafka. You're free to read the information for as long as you want, and the messages do not disappear. The consumers are fully decoupled from the producers in Kafka. They don't care how many producers are producing, or where they're producing, or when they're producing, and the producers don't care what the consumers are doing, and you can have as many as you want, doing whatever you want. So it's pretty cool having just a decoupled system like that. Just keep that in the back of your mind. And Kafka topics are further broken down. So this is the primary unit of storage, but they're further broken down into smaller components called partitions. And these partitions themselves are actually the immutable append-only logs of Kafka, where the individual events are stored. Okay? So Kafka is a distributed system, so it's at this partition level that these partitions are stored on different nodes across the Kafka cluster. And this provides better resilience and also opens the door for replication of data. Okay, so as we add information, you see on the right here, we have a Kafka topic with 3 partitions with some events in there. As we add events to the Kafka topic, as they're produced into there, we'll compute the partition that it goes into, either by a hash of the key or some other protocol, and they're doled out to whatever partition they belong in. All right. So the nodes of a Kafka cluster are called brokers, and these could be bare metal machines. They can be VMs, containers in the cloud, wherever you want to run it. Free to run it wherever you want. In a simple cluster here, where we have just 3 brokers with 3 topics with 3 partitions each, good number, 3, it might be distributed like this. So in the event that a broker were to go down, and the off chance of that, you're at least guaranteed to not lose all of your data, which is pretty nice. You've got some of the information elsewhere. But Kafka takes it a step further, and that's where replication comes in. So if we're just focusing on one topic here with 3 partitions, we have the idea of replication. So replication is a configurable parameter where you determine how many copies of a given partition will be anywhere else in the system, okay? A replication factor of 3 is pretty standard. So in this case, you see that even if a broker were to go down, we ensure that we have our copies, our replicas elsewhere in the system. And so we have our leader partitions, 1 on each of the brokers. And so this is the partition that the clients are either producing directly to or consuming directly from. And in an event that a broker were to go down, a leader election happens, and one of the the follower partitions, is then elected and promoted, and you can just go about your processing again. Okay, so that was my side note on just Kafka in general, but what about Confluent? So Confluent is fully managed Kafka in the cloud, which I think is pretty great. So there's in any sort of distributed system, there's some matter of infrastructure. Who wants to deal with that? I don't. So it's pretty great to have this fully managed in the cloud. You can spin up a Kafka cluster in just a couple of minutes and hit the ground running with it. It's perfect for projects like these when we get back into it, where you want to focus on the actual application that you're building, right? And for me, this is like a project that I'm building in my home. I'm focusing on the hardware. I don't want to focus on the actual managing of infrastructure here. So great for these these smaller projects like that. And on top of offering a Kafka cluster completely in the cloud, Confluent has some great tools built in that help you to integrate external data using Kafka Connect. It bridges the gap between Kafka and external data sources and sinks. We have tools for stream processing, which is KSQL DB. That's completely in the cloud, so you don't even have to leave the web console to do that. And then also additional tools for schema management as well. So we'll see a lot more on this later, but for now, let's get back into the reason we're here, which is my plants, obviously. Okay, so back to the project. So this was the sort of the scratch pad that I originally brought up. Now that I fleshed out a little bit more on Kafka, here are it's more of the details that I fleshed out with regard to this. So I'd start with the metadata, that weird thing that we weren't really sure what it was. After I thought about it, I decided I needed more information on each plant to decide when it needed to be watered, right? So I needed information on the individual plant, some extra bits that to help me, know what data I was looking at. So like, what kind of plant is it? Where is it situated in the house? And then I needed additional information on the sort of like moisture threshold that plant actually likes to be within, And that's typically about like 20% to like 60% for most houseplants, but some of them, give or take. So that could be tunable. So I needed this information, put it in Kafka. The next step would actually be to use the soil moisture sensors to get those readings into Kafka, right? So I'm using a Raspberry Pi to capture those readings from the individual sensors of my plants. And I chose a Raspberry Pi just because it seemed a little more user-friendly, and again, it was on my bucket list. I wanted to use one. And this is my excuse, really. So I'd write a couple scripts then to produce those readings into Kafka. And from there, with both of those data sets in Kafka, I could then start combining them and using them, right? So this is the enrichment step, and I'm going to use stream processing to make this happen and actually determine which of those data readings were actually outliers and when I should actually start to alert on them. And then from there, I could push those alerts. I wanted them on my phone, and I think the easiest way I found to do that would be to push it directly to the Telegram messaging app. And I could conveniently use Kafka Connect to actually bridge that gap and get the data from Kafka to my phone. Okay, so with that in mind, all right, I'm a hardware nerd now. This is pretty cool. I mean, I'm gonna build so many things in my house now. So if anyone actually cares and wants to build something like this, here's some of the hardware that I purchased. Raspberry Pi, this model is absolutely overkill, but there were supply chain issues, So this is the one that I got. I think there's still supply chain issues. Yeah, so with my order, I actually received the breadboard for free, which was really lucky because I ended up needing it. Didn't know that going into the project. And for the soil moisture sensors, I settled on these Stemma I² seed sensors. They're capacitive sensors, which I think hold up better over time. I can touch a little bit more on this later if anyone really wants to nerd out on this project. I think it's pretty cool. But I felt that these were pretty affordable and relatively high quality for what they were. So beyond this first hardware project, so I opted to, very wisely, cut and crimp all of my wires. Got some stories I could tell about that. But anyway, ended up using a couple meters of wire and thankfully had all of the stuff that I needed to do that crimping in my garage, which is crazy. And the most important thing were the participants, unwilling or not. They didn't say anything, so it's fine. I chose these plants in a very scientific way. They're all on the same table, and behind that table was an outlet, okay? I recommend if you're gonna do something like this, be smart about what you're setting up. So I figured for the first iteration of this, I'd make it easy for myself. All right, so with the hardware and the plants decided on, I could actually start building this system. And I'm gonna do some hand waving here because again, it's not a hardware conference, but if you wanna talk a bit later, and I hope that people wanna talk about it later, I'm happy to chat about the process of setting it up. But suffice to say, after a lot of soldering and crimping and maybe a couple tears, I ended up with something like this. And do not judge my soldering skills too poorly. In the end, so you see the sensors in there, that's just from the two of the plants. I ended up using 4 sensors, and this is completely a limitation on the hardware side of things. For I²C, they need to have individual unique addresses, and for these sensors, they could only support 4 unique addresses. So 4 plants in the end, kind of disappointing, but I will be expanding this to have more later on. And I'm gonna, don't look at it too closely. Okay, so the software, that's the more important part. Okay, So on the Raspberry Pi, sorry, it is Python. I know this is the wrong conference for that, but I can't avoid it. Okay, so if you care, here are the versions for the things that I was using. But then the most important part, I think, from the software side of things is that, like I said, I'm building this system. I put a lot of time into that. I wanted the infrastructure to be the easy part, okay? So everything from here on out was cloud-based. So my Kafka cluster is through Confluent Cloud. I was able to do my KSQLDB stream processing completely within the Cloud Console. And I leveraged fully managed Kafka connectors so that I didn't have to leave, again, that cloud ecosystem to bridge the gap between Kafka and my phone. Okay. So every time I talk to anybody about using Kafka, or not even just from the Kafka side of things, but like, how do I start a data-related project, okay? Know your data. I feel like people love to jump into projects and don't really understand the data that they're using. So if everyone just took a step back and thought about what information they actually needed, or what information they had to fetch or create, I think we'd all be a little better off. So I took a step back, and I decided from the get-go that I wanted to have a schema, okay? Schemas are great for just defining that contract between you and any sort of downstream system, all right? So I am the downstream system, so I didn't want to be complaining to myself, hindsight's 2020. So I decided from the get-go that I wanted to have a good schema to start off. So I defined two Avros schemas here. The one on the left is for the houseplants, the metadata, right? And I said I needed information on, to make it easier for me to read the data later on. So what is this plant? Its scientific name, its given name, some of them might have names. And then also the information on that moisture threshold that it's actually comfortable within. The second data on the right is the actual readings data, the information that I'm taking from the sensors. And the sensors that I had captured moisture and also temperature, so I threw that in. Both of these data sets had a plant identification number that I generated and was using to keep track of the individual plants and also serve as a key on the Kafka topic. Okay. So with the schemas defined, I can finally go ahead and put the data into Kafka, all right? There are two main ways to go about this, and these are the Producer API and Kafka Connect. And I know I have verses in there, but it's really not like a competition. There are some pros and cons to each, but you're going to use them in very specific use cases, right? You're not usually going to switch them out for one or the other. So let's take a quick look at those. The Producer API is your low-level, sort of vanilla option for writing data into Kafka. You pretty much have the option of using whatever language you want. There's a way to come up with a client. I personally learned Kafka through Scala and Java. No one's excited. No one's like, I thought you were more like Java people. Anyway, but obviously we have clients for most languages. C++, Python, pretty popular, and more. So check out the resources on that. And then you'll want to use the Producer API when you own the application that's generating the data, or you will be producing the data, or you have access to that, right? So if you wanted to say like capture log events from your application and push them into Kafka, if you own that application, it's 2 lines. You just add a producer and feed that log into Kafka just right there, right? As the information is happening, as these events are occurring. The other option is Kafka Connect. As the name implies, Kafka Connect is a way to connect Kafka with data sources and sinks. In this case, we're just going to focus on the source side of things. Basically, what's so great about it is you don't have to write any code. Love it. It's basically just a configuration file. You point to the data source, add a couple configs in there for like how often you want to pull it from new information. And once you start running it, you have data being fed right into Kafka. And if you're actually using this through Confluent Cloud, as I did, there are dozens of connectors available that are fully managed, meaning, like I said, you don't have to actually leave the Cloud Console to set these up. There are about 100 other connectors beyond that you are free to run on your own infrastructure while still accessing Confluent Cloud, that cloud cluster, if you wanted. Kafka Connect is really great for integrating data from outside of the Kafka ecosystem. So any sort of like auxiliary data sets that you might need as sort of a lookup table from within your stream processing, because that is the biggest no-no that I can tell you, is that when you're using stream processing, you don't want to make a synchronous call. That does not make any sense, right? You're kind of ruining the point of your stream processing. So whenever possible, you want to bring your data sets into Kafka, and Kafka Connect is usually how you go about doing that. Okay, so what did I end up using in my case? Surprise, I only used the producer API, which kind of doesn't make sense. But anyway, I only had, for my metadata is something that you would usually use Kafka Connect to bring in. But as you saw, I had that limitation, and I only had 4 plants worth of data to put into Kafka, so I did not bring up a database for that. So I ended up just having the producer API. I wrote a quick script to push all of that metadata into Kafka, and I was able to assign a completely random plant ID to each of them. And so, yeah, in the future, if I decide to integrate all 4 dozen of my plants, I will absolutely have a database. It doesn't make sense to just have a file sitting around at that point. So watch the space. That will happen, I think. It's a plan. It's a plan. And then I also had another separate script for the reading side of things. I created a static mapping based on those plant IDs that I defined and mapped that to the I2C addresses from the individual sensors. And then from there, it was just a loop. Every 5 seconds or so, I went through, grabbed the moisture and temperature, serialized it according to the average schema that I made, and produced it into Kafka. Okay. So the days in Kafka, how do we process it? There are a couple ways to actually go about this, depending on your use cases and how crazy you're feeling. The OG way to process data in Kafka is to use the producer and consumer API. And the great thing about this is that it's available in all of your favorite languages, whatever client you want to use. But if you're using it for stream processing, it kind of gets a little complicated because you have to handle that whole process, right? You have to consume the data, read the data from Kafka, do any sort of transformations in memory. If you want to have some sort of fault tolerance, okay, you're on your own, figure it out. And yeah, you have to manage that state in memory for yourself, and then you produce it back into Kafka later on. It's a lot of work. It's the lowest level option available to you, but there's a little more flexibility in what you might want to do. I don't know. I haven't seen many applications actually using the consumer producer API for stream processing. So if you're sane, you're probably going to use one of the next 2 options. So moving up, we've got Kafka Streams. Kafka Streams is a Java Scala library. Okay, anyway, just excitement, come on, it's great. For stream processing, it's a library for stream processing. So it has all of that built in for you, right? It takes the hassle of managing state off of your hands. It has, built-in, it uses RocksDB under the hood to store things and manage state. It also backs everything in a Kafka topic, so it has, uses offsets to actually do the stream processing. And it gives you a lot of cool stateful transformations for free out of the box. So you see some of them over there, filtering, mapping, aggregating. You can define your own transformations as well. Joining, windowing, it goes on. So you no longer have to handle that on your own as you would have with the Consumer Producer API. You get it for free in Kafka Streams. And the cool thing is that because it's built on top of the Consumer Producer API, you get the cool things of Kafka for free, like scalability, right? How I said that you can sort of share the work of processing as consumers. So Kafka Streams, you can spin up multiple instances of your Kafka streaming application and have it share the work of processing, and it can consume from the underlying input topics in parallel and then write it back to Kafka at the end. And then it also has automatic failover built in, so if an instance goes down, the information that those consumers from that instance was consuming will fail over to other currently running instances. So it's pretty great. But the easiest and most convenient way to conduct stream processing for Kafka is ksqldb. And what's cool about this is that you don't actually have to, again, no code. It's so nice when you don't have to write any code. But instead, you use SQL syntax. So now, which I think it's so great that you don't have to be a programmer to do stream processing anymore. Think about it. You can hand off, a ksqldb instance to some analysts, and they're happy to go about, they can use ksql or SQL syntax to actually do the stream processing. It's sort of a wrapper around Kafka Streams, so you can do a lot of those things that you can do in Kafka Streams in ksql. And what's cool is that, as I said before, it's that this is offered completely within the Confluent Cloud Console, so you don't have to bring up any additional infrastructure. You can hit the ground running with as soon as you have data in Kafka, you can start doing stream processing with SQL. And this is the technology we're going to focus on today, because again, I didn't have to bring up anything else, right? So There are two main constructs in KSQLDB, streams and tables. So streams represent unbounded ongoing events, right? Tables represent, on the other hand, the current state of an underlying data set, all right? I ended up using both of them, so we're gonna go through these here. So I first created a table from the Houseplant metadata data set. I chose to use a table here because, think about it, if I ever wanted to update one of those values, say, that plant had a lower moisture threshold of 20%, now it's actually good with 15, I want to update that. I want my stream processing application to reflect that changed value immediately, right? So we want to update that table and have it reflect that most recent value as quickly as possible. So the syntax here should seem very familiar. It's basically SQL. The underlying Kafka topic is formatted as Avro. Remember, we made this schema. So the cool thing about that is that we put that additional time in up front, but now we don't actually have to specify any of the fields or their types. So now I don't have to worry about making some weird spelling error. What it can do as a consumer, KSQLDB has access to the schema registry under the hood. It pulls that schema and then can use that to parse the field and type information. So all I have to do here is point to the underlying topic, that houseplant metadata topic, specify the value format, which is Avro, and then I do have to specify one field here, and that's just because we're using a table. The table specifies the most recent value per key, so this table requires that you tell it what value to use as the key, right? Okay, so I take that SQL, and this is the Confluent Cloud Console where you actually execute that. You bring up a KSQLDB application, this one's called Plant Analysis, and then from there you have access to the editor where you paste the SQL, and run the query, and then I now have a table in my KSQLDB application that I can use. And it will constantly just be reflecting that latest value per key. For the readings data, I decided to treat it as a stream because every message is relevant, right? I can replay that sort of history of how much water the plant had over time, and I want to be acting on every message that comes in. Again, we're using Avro, so this is actually even easier. I don't have to specify any of the fields. I just point to the topic, specify the value format, and KSQLDB will use the schema to infer everything about the underlying topic. So now I have both of these data sets in my KSQLDB application. The metadata is in a table. My readings data is accessible as a stream within the application. And now I need to combine them, right? Because they're not very useful on their own. This will help me, by doing this enrichment step, it'll help me do the processing later on, right? So to enrich the data, we have two data sets. We're operating over SQL. It's a join, okay? And the syntax is pretty much the same. So we're going to focus on this select statement first off. So it's a stream to table join. And I'm using an inner join here because I want to make sure that I have all the information from both data sets in order to do the processing in the next step, okay? So I point to the readings data. We conduct the inner join on the metadata. Similar to just a regular SQL join, you point to the field that you're actually joining over, and then you conduct the select of whatever fields you want to output. You'll notice here that similar to a select statement, okay, that's going to output some information. But I want to persist this. I want to use this information in my next step. So I want to persist it to a Kafka topic, all right? So we're going to take the result of that select statement, and we're going to push it back into a Kafka topic, which is where this create stream statement comes in. So in this case, compared to the last one where I was saying create stream from a topic that already exists, in this case, we're creating a stream from information that we are generating just now, okay, as a result of this query. So in this case, this create stream statement will create a stream backed by this topic. So the information that we're creating as the output of this query is going to be persisted to this Kafka topic. We're going to store it as Avro. And then also on that note, you'll notice that we have emit changes at the bottom. That's a crucial keyword here. So this phrase indicates that we're using a push query. So this means that the result set will be an open-ended stream of information that will be pushed to me as output. So think about it. The houseplant readings stream, every time a new piece of information arrives on that stream, it will be processed through this streaming application. Joined on the metadata, we'll select the fields from it, And we're going to take whatever new information from that and push it onto the stream. So it is a stream processing application at this point. We are always going to be adding those, the new events as they come in, processing them, and feeding it into this stream that we're creating. So this is contrasted with a bounded pull query, which is also available through KSQLDB. And this is where I'm pulling a finite result set that reflects the current state of the underlying streaming application. So this is an example of a pull query where I just wanted to see, this one-off information. What is the given name from all of my houseplants that whose moisture low threshold is over 20%, right? And that's going to populate or spit out the names of those plants there. And this is what you'll see through the Confluent Cloud Console. Okay. So now I have all the information enriched. Okay, now I can start to act on it, right? What's the overall goal here? Whenever a plant has enough low readings indicating that it needs to be watered, I want to send an alert, all right? But how do I send that alert? How do I determine when an alert needs to be sent? And how often should I be sending them? So this is an entirely design decision, right? I decided that I didn't want to inundate my phone with an alert every 5 seconds, because that's how often I was taking these readings, right? In the event that I'm out of the house, or I'm busy, or I'm at a conference, I figured that an alert once an hour would be enough time for me to either act on it when I'm in the house, or text my partner and tell him to do it, right? I also noticed, and this factored into it, that my sensors weren't perfect. Okay, if any of you have done any hardware projects, it's never that easy. The sensors seem great, but sometimes they're a little off. So I could occasionally get false low or false high readings, but the general trend was that the moisture value would be decreasing over time. Okay, so within a given 1 hour period, I figured it was good enough if I received 20 minutes worth of low readings. Then I knew that it was serious, right? It wasn't just false low, false high. This is actually the state of that plant. So since I'm taking readings every 5 seconds, I should be getting 240 low readings before I actually trigger an alert. So this is the query that I wrote to achieve that. All right, so we're gonna break this down. It looks a little intimidating. I said I wanted to receive an alert every hour, so I set up a query to aggregate over non-overlapping 1 hour windows. So you see that here. There's one line, and it does the windowing for you. It's crazy. And I only care about the enriched rows where the moisture reading level was lower than the lowest moisture threshold. All right, so that's that where clause. And then I only want to trigger an alert when I've received 240 of those. So now we have that having clause in there. So when I get exactly 240 readings, within that window, a result is emitted. And that might seem a little wonky, so I'm just gonna explain this a little more. So this is a stream processing application under the hood, okay? When we're windowing and we're conducting an aggregate, the output is a table where each row is computed per key per window, okay? And that makes sense because a table reflects the latest value per key, all right? But the query is operating over the full set of records, right, from the input stream in real time, okay? So it has this underlying state associated with it, and that's where that count star comes in, right? So every time a record comes in and it actually meets that moisture threshold level, it is added as part of that state, okay? That state is aggregating within that single window, right? So per plant ID per window, when we encounter a reading that actually meets that requirement, we're updating the state, okay? Readings 1 through 239 are just gonna simply update that state. And then as soon as we get the 240th reading, we're going to output a result, right? So this achieves that goal of, I only want to receive one alert per plant per hour at most, right? So that's exactly what this does here. And again, just to tie this up a little bit, we are populating that into a table similar to the last query. We're taking the result of this query, pushing it into a table, we're backing it by that Kafka topic, and again, we want the results as their output, so we're using emit changes. Okay. So the information's in Kafka. I know what plants need to be watered every hour now, okay? How do I get it out of Kafka? So I said I wanted to receive this on my phone, and again, I wanted to minimize the amount of time it took me to really hit the ground running with this, so I opted to use Telegram. Telegram, really cool, you can set up a bot. It's crazy what you can do now. Wow. You can set up a bot and start conversations with it. And once you do that, you have a unique chat ID that identifies that chat. So taking that chat ID, you take it a step further. Now they have a chat API, so you can use that chat ID and push messages to it whenever you want, right? So I have a URL. I have an endpoint. Kafka Connect HTTP sync. If you have an endpoint, you can push data to it. So this is actually a fully managed connector available in Confluent Cloud. So again, didn't have to spin up anything on my own. It was actually just some drop-down configurations, some text boxes I populate with the URL, make a couple decisions in there, and run it. And then it's able to start processing. It's using the messages from the underlying Kafka topic as triggers then to send the messages to my phone. All right, and I said that it was configuration-based, and you could do so through a series of drop-downs, basically. But this is the configuration file that's spit out at the end, just so we can review it. So we're pointing to the Kafka topic that has those low readings in it, the alerts, specifying that it's Avro. Again, here's the endpoint that we're actually going to, and it has that chat ID in there. And then the low readings topic has a message field in it. That is actually the message that I want to submit to my phone. So I use regex to capture that text and feed it out into the text field that the Telegram API requires. And then in the end, I get a message like this. So now I conveniently get a message on my phone every time my plants need to be watered. Bradley needed to be watered today. And yeah, so it's pretty cool. I think it's pretty cool. I was able to do this in just a couple days of development. It really was not that difficult to get this thing up and running. And like I said, this was my first hardware project. So it's pretty cool to actually see the result of this actually working. And it's in production, okay? It's in production, guys. If anyone is curious about getting started with these sorts of things, if either you're a hardware buff or you want to check out Kafka, because I think it's pretty awesome. On the left here, we have our Confluent developer Java resources. I just made a gross assumption there that everybody wants to use the Java stuff, but no, you guys just didn't care, man. But from there, you can easily get to all of the other client resources that we have in case you want to do something else. And then on the right, I have the repo with all of the scripts that I wrote, the KSQL that I actually utilized as well as the configurations that I used for the connector and everything. So yeah, if you're curious about it, I definitely recommend checking it out. And I can take some questions now. Yes?
So the table definitions you had,
yeah.
Do you need, like, is that, like, do you run it, like, only one time, like a migration, or, like, how do you keep updating your tables on your stream?
So this?
Yeah.
Yeah, so you submit that once, right? So I'm manually writing the data into that houseplant metadata topic, right? So whenever I need to update that, in this case, I would need to produce that message into Kafka, but you only have to run this create table once in KSQLDB. So it will constantly, every time a new message comes through on the underlying Kafka topic, it's going to update that table within that application.
And what about the stream?
The stream? Same thing. So I have that script that's constantly pulling and pulling data from the sensors and producing it into Kafka. I run this once, and now it's accessible from within the Kafka, the KSQLDB application. And every time a new message comes through on the houseplant readings underlying topic, it's going to be processed. Yeah, good question. Yeah?
I was interested that you use a table for like the alerts rather than a stream. Why was that?
Yeah, it's because you're doing an aggregation. It's aggregation and windowing. And that's just because, as I tried to explain, as it's processing the individual records that come through, it's updating state, and you can access that sort of like partial result at any point. And again, because it's a result per key, it's a table, yeah. But you can actually, I was playing around with this, I don't know if it's even recommended, but you can kind of feed this table back into a stream if you wanted to do more processing on it downstream from the stream, yeah. Any other questions? Cool. Okay, well, I'll be available if anyone wants to nerd out on any sort of hardware projects. I'm looking for suggestions, and yeah, or Kafka. I love Kafka too. Stop by our Confluent booth. We've got one downstairs. We've got some cool swag, and we're talking about some cool demos we have running. So if you're interested in seeing some stuff in action, I recommend stopping by. Cool.